Hi students, so we are continuing motion in a plane. Okay, we just had a small introduction about vectors. Okay, so physical quantities basically we divide into scalar quantities and vector quantities. So the physical quantities which has only magnitude, that is a numerical value and its units, then we can say they are scalar. Say for example, if some of your friend coming to you with fever and you are asking him or her like do you have fever, how much is the temperature, then they will be telling 101 degree Fahrenheit. Okay, so whether what is the unit, whether 101 degree Fahrenheit or 101 degree Celsius or 101, its unit, different units are there. Generally when we say 101 Fahrenheit is the unit we say when we tell about the fever. So we will not ask whether you have fever in the right direction or left direction. We won't ask, right? Fever means fever, 101 degree Celsius or 101 degree Fahrenheit, not degree Celsius. Okay, this is what. Suppose if this is a road, okay, so here there is a shop, okay, hotel is there, someone came here, okay, some person came here, another person was there, then he asked him where is the hotel, then he said 2 kilometers away from here. He said just 2 kilometers away, so 2 kilometers away. So he went straight. Then here he met another person. Here this is about around 2 kilometers. Asked him where is the hotel. One guy told me that 2 kilometers away hotel is there. Then he said no. Now if suppose if this is 2 kilometers, he said no, hotel is again 4 kilometers away. If just like this person, if he also says the same thing without mentioning the direction, then again there is a chance that we will move further again searching for the hotel. But what he should say, you should go south or left, whichever way they can, then you should turn. Likewise he should mention the direction. So there are physical quantities which require direction. Okay, just like, okay, so we can say 101 degree Fahrenheit. This information is complete. We don't need to add anything here. But suppose someone is moving, okay, he is moving 2 kilometers. This information, 2 is the magnitude, kilometer is the unit, but absolutely no idea in which direction he is moving. So what we should say, 2 kilometers east. If someone says 2 kilometers east, okay, then direction also came there. Okay, the information is complete. Okay, so this is the requirement of vector. So something to be vector, it should have magnitude and direction. At the same time, it should obey vector algebra, or it should obey vector law of addition. Vector law of addition. Okay, so it should follow vector law of addition. Scalars means simple addition we can do. Okay, so this is the need of the vector, and what are the conditions, okay, for some physical quantity to become vector. It should have a numerical value, it should have a unit, at the same time it should have a direction. Along with that, direction alone is not sufficient, it should obey vector algebra, or we can say vector law of addition it should follow. Okay, clear? Okay, then how do we represent vector? If something is vector, we will put an arrow. Okay, we will say this is a vector. And graphically, how do we represent vector? Okay, see this kind of line with an arrow mark. Arrow mark indicates what? This is head, this is tail. If this A is 5 Newton force, then just like this graphically we will mark this. Say for example 1 centimeter is equal to 1 Newton, then 5 centimeter is equal to 5 Newton. In graph we will be plotting. Suppose if this is 1 2 3 4 5 centimeter means this says that this is 5 Newton. Based on, we can mark the direction could be in this direction or in this direction or this direction, any direction. Okay, any direction can be given. Clear? Okay. And then how to find a magnitude of a vector? Simply if we say mod, or if we write simply A without putting this arrow, all these are what? Magnitude. Magnitude means the number associated with that, Suppose if we say 5 Newton east, so this is direction, this is actually its unit, and this 5 is what is magnitude. 5 is what is magnitude. Then in the last class we have seen how to find unit vector A divided by modulus of vector A, that is magnitude of vector A. So magnitude of vector A is nothing but root of the coefficient, sum of coefficient square. Just as an introduction we have seen how it came, and all that discussion we will do later. Just I have introduced that formula. Then unit vectors, more importantly we have discussed about unit vectors. Unit vector along x direction is I, unit vector along y direction is j, unit vector along z direction is k. Okay, unit vectors I, j, k are just to denote if the vector is in the direction x or y or j. So certain vectors will have directions in between x and y, so we will have to use I and j. 3-dimensional vectors I, j, k we will have to use. All these things we have seen, again we will discuss on that. So now today which I am going to discuss is, suppose if we get north, south, east, west, these kind of situations. Okay, then what we do, we will be marking like this. Something is moving in this direction, we will be marking east, north, south, west. Okay, suppose if something is in this direction, something is in between north and east, what we write? Northeast we write, northeast. If something is in this direction, okay, what we write? Northwest. The direction is between west and north, what we write? Northwest we write. If something in this direction between south and west, exactly this is actually 45 degree, this is also what? 45 degree. So 45 degree to north or 45 degree to west, what we write? Northwest. Here again, if it is 45 degree to west, what we write? We write southwest. And for this, if this is 45 degree, we will be writing southeast. Clear? This is how we write. In between, suppose if we are getting a direction close to east, say for example if this is 30 degree, then what we write is, this is near to east, so we can write north, we can write 30 degree north of east, we can write 30 degree north of east. Same way, suppose if we are getting just like this, suppose if this is 20 degree, then we write 20 degree west of south. Okay, so whichever direction is near to it, okay, whichever direction is near to it. Say for example, if here if we are marking like this, here it is 20, then instead of west of south, what we write? 20 degree south of west. Okay, likewise we can mark. So whichever be the direction is prominent, it will be tilted to another direction, means that direction of this one. That is how we write. Hope things are clear. Okay, this is how we mark. Clear? Note it down. So suppose, can you draw the vector which I am telling? 5 Newton 37 degree east of south. 5 Newton 37 degree east of south. How to draw that? Okay, please draw this. Please pause the screen and draw this. Okay, so north, south, east, west. So 5 Newton 37 degree east of south. So basically the direction is south. So 37 degree east means east is this. So we can write like this. Okay, this will be 37 degree and this is going to be 5 Newton. Okay, this is how we should mark this direction. Clear? Okay, suppose if we are drawing it in a graph, okay, then this 5 Newton we will have to mark like 1, 2, 3, 4, 5. Okay, this is how. Okay, 5. This will be actually 5 Newton. Okay, so that length actually we will have to mark just like 5. Okay, just like this 1, 2, 3, 4, 5. Okay, so 1 centimeter is equal to 1 Newton. So 5 centimeter we will be taking as 5 Newton. Clear? Now certain basics are there, certain important points from the basics of the vectors that I will give you. Okay, that will be helpful. Okay, important points. Okay, important points related to vector. Okay, important points related to vector. First point is on rotating 2 pi. Suppose if we are rotating complete, okay, vector doesn't change. Vector does not change if we do a complete revolution. Say for example, if this is the vector, okay, if we are rotating like this completely, this vector will be staying as such. If we completely rotate 2 pi from here, this is actually 2 pi. Okay, that is one point. Another point is a vector can shift parallel to itself. A vector can shift parallel to itself. This is coming from actually the concept of equal vectors. From the concept of equal vectors, already we have discussed. A vector can be placed anywhere without changing its magnitude and direction. So a vector can be shifted. A vector can be shifted parallel to itself. Suppose if this is a vector, this vector without changing its direction and magnitude I can shift anywhere. So all these are, if this is vector A, this is also vector A, this is also vector A. Clear? That is the second point. Anywhere I can place. What is the advantage of this? One advantage of this is, suppose if we have placed a vector like this, okay, suppose if this is something, this is something, say if this is -1, this is -3, and if this is -2, this is -1, this is the vector. Now suppose this vector, if we place here, this is not that comfortable for us. What we do, we can shift from the origin. So this is 2, this is also 2, we can shift from here to here, so that understanding and doing some certain operations on this vector will be easy for us. So we can shift it anywhere. Take the third point, the angle between two vectors. The angle between two vectors is the smaller of the two angles between the vectors when they are joined tail to tail. What is its meaning? So suppose if we are getting two vectors and we need to find the angle between two vectors. So this is a vector. Suppose if this is another vector, this is vector A, this is vector B. What is the angle between this vector? Suppose if we think in this way or if we think in this way, which angle we should take? This is the discussion here. So the angle between two vector is the smallest of the two angles. So this is also one angle, this is another angle. We should take this angle, smallest of the two angles between the vectors when they are joined tail to tail. So this is tail, this is head, this is head. So this thing we can clearly take only if we join the vectors tail to tail. We know equal vector concept and we know parallel shifting concept also. If we want, without changing the direction, we can replace the vector anywhere. Direction should not change. So just by adjusting tail to tail, we can find the angle between the vectors graphically. Okay, mathematically, just by writing, okay, by analyzing or just by using formula, there is another method. This is graphically I am telling. And if you think like that, then the angle between the vector will be between 0 and 180. The angle between the vector could be 0, or it can be greater than that, or it can be 180 or less than that. Beyond this, angle of vectors will not go. This is the important point. See this question. Find the angle between vector A and vector B. So vector A is given, vector B is also given. So what is the angle between vector A and vector B? So this angle, if we know, if this is given 300 degree, we should not take the angle as 300 degree. This is wrong. We should take the minimum angle, correct? Remember, according to the third point. So total is 360 degree. So this angle is 60 degree. So here the angle between A and B is actually 60 degree. Clear? Take this question. Same question. Find the angle between vector A and vector B. So this is vector A and this is vector B. This angle is given as 120. Okay. So what is the angle between vector A and vector B? So you pause the screen and try yourself. Every question you just try with me. Now how can we take? See, if this is 120, this is actually 240. Is this angle between A and B? No, this is also not right. First task is to make tail to tail connection. We should redraw and we should make it in such a way that the tail of A and tail of B must be together. So what we will do, we will take this vector from here and we will fit it here. Parallel shifting, both are equal vectors. So I can take like this. So this is also what? Vector B. Now if this angle is 120, that is already given. Okay, this was vector B, we have shifted here. Now this angle is 120. Actually this total is how much? 180. This total is how much? 180 degrees. So this is going to be 60 degrees. So the angle between vector A and B is equal to what? 60 degree. Clear? Okay, just join the tails, then apply basic geometry, then get the angle between the vectors graphically. Okay, note it down. So take this question. Find the angle between A and B, A and C, B and C. This is vector A, this is vector B, and this is vector C. Okay, so pause the screen and try yourself. So first one is between A and B. So we will redraw them. Okay, so vector A, this is at an angle 30 degree. This is vector A. Now vector B, in order to find the angle, what we should do? Either we should replace this vector A here or this one here. Better, all the angles are marked here. So replace this vector B here in order to make the tails touching. Okay, so without changing its direction, we should mark. So suppose if this is the vector B, what we should do? We will replace this vector B like this. So if this is 60 degree, then what about this? This also will be 60 degree. This is vector B. Clear? Now this total is 90 degree. So 30 degree plus 30 degree, we will be getting 60 degree. That is the angle between vector A and B. Now let us try vector A and C. So vector A and C is already here. The tail of vector A is here, tail of vector B is here. Since this is 45 degree, we know this is anyway 45 degree, easy. We will be getting how much? 75 degree is the angle between A and C. Okay, so you also found the angle between B and C, right? So please work with me, dear students. Okay, just imagine like we are interacting. Okay, just like a normal class. Definitely you should sit with that discipline without any distraction, with a pen, paper. Okay, not telling this because I feel like okay, you are serious about all this. Okay, so please do like that, work with me. Okay, you also try to solve. What about between B and C? So the head of B is here, tail of C is here. So what we will do? We will redraw that. Okay, so vector C is like this. This is 45 degree vector C. Now if we need to replace, okay, if we need to replace, this is how, actually this is how vector B is. 60 degree gap is there. So if this is vector B, in order to replace this, it will come here actually. So this comes like this, vector B. Whatever angle is here, that will be the angle here actually. The angle here is like that. Okay, this 60 will be same as this. 60, 60. Likewise, if we shift here, so 60 minus 45, how much will come? That will be the angle between vector B and C. So 45, we will have only 15 degree. So the answer for this is 15 degree. Clear? Okay, graphically the angle between two vectors. Students, we have seen the different types of vectors. We did equal vectors, collinear vectors, unit vectors and all. I'm just doing a quick recap of that. Suppose if it is equal vectors, suppose this is 2 meter per second towards east. This is velocity. If this is a vector, then this is velocity. Suppose another vector, okay, 2 meter per second towards west. Okay, so here the magnitude of vectors, okay, suppose if this is v1 and if this is v2, so magnitude of V1 and V2 are same. Correct, no? Magnitude of V1 and V2 are same. Magnitude of V1 is 2. Magnitude of V2 is also 2. One condition is this, okay, for something to become equal vectors. What is the other thing? The direction alone, if we consider, what we should put? V cap. Direction of a vector, how we address direction alone. Full vector will have direction as well as magnitude, sorry. So if we need only direction, what we will put? V cap. So whether V cap is equal to V2 cap? No. Its direction is actually east and its direction is actually west. So this is not equal vectors. They are not equal vectors. Another discussion is, suppose if this is 2 meter per second east, then same way 2 Newton east. So one is velocity vector acting in the east direction. 2 is the magnitude. Okay, so magnitude is same. Suppose if this is V1, simply we can write V and this is F. So we can write magnitude of V is equal to magnitude of F. Both are same and this is nothing but 2. Correct, no? This is 2. Another thing is, what about the direction? V cap is equal to F cap. Is it true? Yes, both are same. But the problem is the unit of V is not equal to unit of F. Okay, this is not same. So again we can say this is not equal vectors. Clear? Okay, so something to be equal, we need to have its direction, magnitude, unit. Everything should be done because we have to add vectors. So velocity we won't be adding with the displacement. When you do addition, units must be same. You might have studied that in units and dimensions. All the equations which we have studied, V is equal to U plus AT. What is its unit? Meter per second. Here meter per second, here meter per second square into second tuck. So when you add, we won't be adding apple with the orange. We will be adding only apple with the apple. So unit must be same. When you multiply, that is not a problem at all. So equal vectors. Okay, one more condition which we have seen. Okay, clear? So different types of vectors. Another topic in the different types of vectors, what we have seen? I think we have seen parallel vectors, collinear vectors, coplanar vectors also. Okay, parallel vectors, collinear vectors, then coplanar vectors also we have seen. So suppose for something to be collinear in the same line, if this is a vector, vector A, it starts from here and here. Same way I have another vector. Okay, its magnitude need not be same. They are all collinear vectors. Okay, all these are collinear vectors. And another vector is acting in the opposite direction. Okay, that is also collinear vectors. If one vector is going like this, this is vector A, this is vector B, this is vector C. All these are collinear. Okay, A, B and C. All these are collinear vectors. Now suppose if this is vector D. Okay, they are vector A and vector D. They are what? Parallel vectors. They are parallel vectors. Let its length be little bit smaller also, no problem. This is this much long. Okay, the magnitude of vector A is greater than magnitude of vector B, still no problem. It is parallel vectors. Okay, so collinear vectors, same line. Parallel vectors, same direction. What about anti-parallel? If this is a vector, another vector parallel but in the opposite direction. If this is vector A, this is vector B, okay, then vector A and vector D, they are anti-parallel. They are anti-parallel. Clear? Okay. Now negative of a vector. Negative of a vector. No one will ask what is parallel vector, what is anti-parallel vector and all. They will be asking a question. Okay, we have done a problem in the last class also. Given a vector B. Okay, then vector A also given. Okay, find a vector which is having magnitude of A and which is parallel to B. Then what we did, we found the direction of B just by finding unit vector and we multiplied with the magnitude of A. So likewise they can ask, okay, what is parallel, anti-parallel to this? Then we will have to find the unit vector, we will have to change the direction also. So we need to understand what is negative of a vector. Negative of a vector. Suppose if this is a vector, okay, then negative of a vector, if this angle is 45 degree, then we will have through origin, okay, through origin, okay, we will have the same vector, okay, just flipping it. So direction will be exactly opposite. If this is 5 Newton, this is also will be 5 Newton but in the opposite direction. So minus will be there. Okay, clear? Negative of a vector. Suppose if we write 2 meters east, 2 meters east, if this is vector A, then minus A will be what? 2 meter west in this direction. So likewise we can have negative vectors also. Okay, so magnitude must be same. Okay, magnitude must be same. Suppose if we have 2 meters east, 4 meters west, okay, whether they are negative vectors? No, not negative vectors. Okay. The reason is, if this is vector A and if this is vector B, then magnitude of vector A is not equal to magnitude of vector B. That is the reason. Another type of vector which we have discussed is coplanar vectors. Coplanar vectors means vectors that are in the same plane. So if we consider two vectors, if we consider two vectors like this, always they are in the same plane. If I tilt this, this is also a plane. If I tilt this, this is also a plane. If I tilt this, this is also a plane. So all these are planes. So if we consider two vectors, they are always in the same plane. So I can write two vectors. Two vectors are always in coplanar. Two vectors are always coplanar vectors. Two vectors, because they will be always associated with some plane. Okay, need not be this plane or this plane. Okay, this plane. Okay, x, y, z. It can be any plane in between also. For us, this is x, this is y, it is z. For someone who is taking class on the other side of the globe, okay, he may have this as x, this as y. Okay, so it's all we take. So 2 vectors will be coplanar always. Suppose if we take 3 vectors, okay, so this, if they are like this, okay, then we can say they are coplanar vectors. But if it is tilting like this, okay, this is not of same plane. So 3 vectors may or may not be coplanar. Clear? So these are the type of vectors. One type which we have not discussed in the last class is nothing but concurrent vectors. Concurrent vectors is nothing but they are operating from the same point. 2 or more vectors operating from the same point are called concurrent vectors. Okay, 2 or more vectors interacting at the same point. 2 or more vectors interacting at the same point, they are called concurrent vectors. Okay, so here vector A, vector B, vector C, they are concurrent vectors. They are interacting at the same point. Okay. Or one more thing is, if there, or this is one condition, another condition, if their line of action, is a single point, if their line of action is single point, then also what? Concurrent. Okay, say for example, this is one vector, this is another vector. So if their line of action is this, so one more vector is acting like this. So this vector, vector A, vector B, vector C, they are acting in different directions, but their line of action is joining at this point. So this is also concurrent vectors. Sometimes different forces will be acting at a single point. Okay, that they are all concurrent vectors. Okay, so sometimes when you read some definition of some laws, they will be telling concurrent vectors. You should have this understanding, then only we will be able to catch those points. Okay. So unit vector, the magnitude is 1, we know. Just to show direction only, unit vector we use. There is something called zero vector also there. What is the zero vector? See, when you multiply, generally scalar multiplication, when we do 0 into 2, 0 into 3, when we do, we will be getting 0 answer. Vector multiplication we will be seeing, okay, we haven't touched it, we will be seeing there is 2 types of vector multiplication. Vector into vector we can do in 2 ways. 2 methods, not actually. Actually vectors will multiply by its own wish. It has its own way of multiplication. So we will have to find it and we will have to understand it. It is not a law like we are telling like this is how it happens. Okay, it should happen. They will multiply in the way they want in nature. We have just understood, that's the thing. So dot product and cross product is there. So sometimes even if you multiply some non-zero value into non-zero value, particularly when we do cross product, okay, just I am giving you the word, we will study in detail. When we do cross product, sometimes we will be getting a 0 result, but that 0 is also a vector. The result of cross product multiplication is a vector. The result of dot product multiplication is a scalar. First time I am telling this sentence, I am not going into the detail of this. We will be repeating the concepts again and again. Many points we will be telling the concepts. Just then only it will go inside the mind. If I tell this and if I leave, you will forget that. So first time I am telling this sentence, the resultant of cross product or the result of cross product is a vector and the result of dot product is a scalar. Just by cross product multiplication we will be getting a vector baby, and just by doing dot product multiplication we will be getting a scalar baby. When you multiply using cross product, the result or the product or the output will be what? Vector itself. It will have direction and magnitude. When we multiply something with using dot product method, what we will be getting? We will be getting a scalar, just a number without any direction. So when we do cross product, we will be getting, suppose if we are getting answer as 0, magnitude will be 0. Magnitude will be 0. Magnitude will be 0, but direction will be there. So direction will be there. What will be the direction? Arbitrary direction. That is any direction, we do not know. But if they ask whether it is scalar or vector, we will have to tell boldly that it is a vector, but with the 0 magnitude. Okay, minute details, let's learn that also. Okay, so that is what about 0 vector. You need not confuse just by thinking about cross product and dot product. Just remember, put that sentence in the mind. The result of cross product is vector, result of dot product is scalar. Just keep it in mind, we will get into the details of that. Clear, all of you? So types of vector, we have seen 0 vector also. So dear students, now slowly we are moving into vector addition. Okay, vector addition. Graphically, first we should understand them graphically, then we will move into the formula and all. So three laws are there, okay, for vector addition. Okay, okay, 3 laws are there. Number 1, triangle law of addition. Triangle law of addition. Number 2, parallelogram law of addition. Number 3, polygon law of addition. Polygon law of addition. So first we will see today triangle law of vector addition we will see, and parallelogram, polygon law and all we can see later. Okay, it's graphically how the vector addition will happen we will see today. Triangle law of vector addition. Note it down. Look at the definition. Triangle law of vector addition. You may not understand the definition. Okay, just read it. We will explain, then we will go back to this. If two vectors are represented by two sides of a triangle in magnitude and direction, taken in same order, then the resultant is given by the third side of the triangle in magnitude and direction taken in opposite order. Didn't understand anything, right? Okay, will not understand, no problem. See, leave it. First you just understand, suppose you have studied about distance, displacement and all very clearly. Suppose, see, suppose from this point A to point B 10 meters distance is there. Okay, so after reaching here it further traveled to C. If this distance is 5 meter, then can you tell me what is the distance traveled here? 15 meter. This 10 plus this 5, 15 meter, done. What about displacement? What is displacement? 10 plus 5, again 15 meters. Straight line motion, no change in direction. Distance and displacement both are same. Suppose if that is one case. Another case is move to B, from A move to B, again 10 meters. Okay, correct. Return back to C. So C is here. Again, this is 5 meters. What is distance here? Distance is equal to this 10 plus 5, 15 meters. What about displacement? Displacement is what? This 10 minus 5 we will have to do, right? Displacement will be what? This is the initial point. This is the final point. So this distance is this 10 minus 5, how much? 5 meters. Correct? Suppose if this is point A, see the difference. 10 meter further in the same direction. So here the angle of movement from here it is 0 degree. Again we are getting 15 meter distance and displacement. In this case, after going there it came back. So this displacement is 5 meter. Now see, from A the person has traveled 4 meter in the east direction. So this is actually initial point, this point. Then after that turned and moved 3 meters in the north direction. So this is the final point. So what is the displacement? We have studied, no, the closest straight line path between initial point and final point. So what we will be getting this as 5. Okay. So suppose if we change this as 4 meter and this is again 3 meters, same distance only traveling. So distance what we are getting? We are getting 7. Here again we are getting 7. In this case, suppose if we traveled this as 4 meter, again if we traveled back 3 meter, then the distance will be how much? 7 meter. The displacement will be how much? 1 meter. So the distance covered is same in all the 3 cases. 7 meter. Here also what is the distance? Distance covered is 7 meter only. Everywhere distance covered is 7 meter. So if this is A and if this is B, A, B, likewise if we take, since distance is scalar, directly we can add A and B. Correct? No? Directly we can add A and B. But in the case of displacement, when we add or when we try to find the result, actually based on the direction, based on the angle, the result is varying even though the person is traveling the same distance. Okay, clear? Did you understand the difference in the example? Okay, shall I erase this? See, just by changing the direction, distance doesn't have any change, but the displacement is changing here. Why? Because displacement is vector and distance is scalar. So the result which we are getting is varying just by changing the angle or direction. So that is why in physics, if vector A plus vector B, when you add, not the case of distance, we are studying the case of displacement, velocity, force, acceleration, all that. That is why we are using vector. Vector A plus vector B is equal to, here this can be C, X, whatever we want we can write, but the name we use in physics is resultant. So this resultant can be 7, this resultant can be 1, this resultant can be 5 based on the angle between these two vectors. So when the angle vector A and further vector B, this is 4 meter displacement, and when this is 3 meter displacement, when the angle were same, displacement we got as 7 meter. But when we had 4 meter vector A, further in the opposite direction B is equal to 3 meter, the resultant, that is the displacement we got, is 1 meter. Suppose vector A is equal to 4 meter, vector B is equal to 3 meter, then the resultant we were getting, the displacement we were getting was how much? 5 meter, root of this square plus this square. Okay, so based on vector A, vector B, vector A, vector B, vector A, vector B, here theta, the angle between vector A and vector B is 180 degree. Vector A, 4 meter traveling, vector B again 3 meter traveling, angle between vector A and vector B is 0. The resultant is vector A plus vector B, directly we are getting 7 meter. Vector A, from there vector B in the opposite direction, the sum of these two vectors, or we can say the resultant of these two vectors, depends on its angle. Vector A, vector B, the angle between them is 180 degree. The result we got here is just 1 meter. Vector A is in this direction, vector B is in this direction. The displacement, the resultant between vector A and vector B, they are acting at an angle, vector A, vector B, they are acting at an angle 90 degree. So the resultant was changing. Clear? So last time we got 5 meter. So this resultant depends on the angle in which these two vectors operate. This is the thing which I am trying to tell you. Simply, if I tell you, you need not believe. So I am taking these examples and telling. Okay, so this has what? Magnitude and direction. Okay, these two vectors have magnitude and direction is there. Correct? So its name is resultant. Whatever we are getting, its name is resultant. This also will have magnitude and direction. Okay, now I shall explain what we are defining here. Note it down. Read this definition. If two vectors are represented by two sides of a triangle in magnitude and direction, vector A, one side of the triangle, okay, so its length shows its magnitude and this direction shows in this way, that is direction. Now this is vector B, this is another side of the triangle, taken in same order. Taken in same order means you can consider this as anti-clockwise. Head is going in this direction, head is going in this direction, in this direction. If we draw like this, this is in the opposite order. So this is the same order. So if two vectors are represented by two sides of a triangle, magnitude and direction, taken in the same order, then the resultant is given by third side of the triangle. This is the third side of the triangle. Resultant is given by third side of the triangle in magnitude and direction, taken in the opposite order. Taken in the opposite order means in this order. So this is the opposite order, clockwise direction we can think. Okay, so this is what is the definition. If vector A is one vector, vector B is another vector. If we are trying to add vector A and vector B, then the resultant, we call the name as resultant. Okay, the addition, the result of addition is called resultant, which will be graphically will be the third direction of the triangle in the opposite order. This is what the definition says. Okay, so we did a quick recap of a vector. Again, we discussed about vector a little bit. Now I have introduced a triangle law of vector addition. From the next class onwards, once again I will explain this. We will do some problems and we will continue like that. So slowly we will go. If we understand vectors, then first milestone is done. With the understanding of vectors only, we will be able to operate things in physics. Otherwise, physics will become very tough. Okay, students. So winding up the session. Thank you. Goodbye. Good luck.